guys, welcome back to another math problem.
All right. So day one, functions. Day one, functions. Let's go ahead and start at the very top. Really what it's kind of talking about is 8th grade. You learn to express mathematical relationships using a coordinate graph. Relationships can be represented by a set of ordered pairs called a relationship. Have y'all ever heard of this right here? Ordered pairs? You have? Yeah, one or two. So ordered pairs, all that is, it looks like this right here. It looks like it has an X and it has a Y. That's what an ordered pair is, okay? Parentheses, and you have an X and you have a Y. Do y'all know what the X means? No? Good. So the X means inputs. It's what you input. You're going to put something in, right? And the Y has to be output. If you put something in, you're expected to get something back, right? If you put $1 into the vending machine, what are you expecting to get out? What you wanted, right? The food you wanted or the drink you wanted. So the input was the $1. The output was whatever you got. Does that make sense? So, if you input $30,000 to a car dealership, what do you expect to get out of that? The car, right? Yeah, the car, whatever car it is that you wanted. So the input was, I gave $30,000. The output is, I get a car, okay? If you input an hour's worth of studying, okay, what should the output be? You're getting a good grade. Does that make sense? So if I put in 2 hours of studying, will my output be the same as the 1 hour or better? It'd be better, right? Because I put more time into studying. Does that make sense? So we got input and output. Input, output. And that's kind of what this next part kind of talks about. It says a function maps each input to one and only one output. So we got to make sure we write that. Okay? So a function, okay? A function, every x or every input has only, I'm going to put this in caps right here, only one output, or y. So every x only has one output, or y. Every x has one input or output, which is y. All right? And all of the inputs, what this kind of says over here, all of the inputs are considered to be your domain. So inputs are your domain, and outputs are your range. Output is your range. What letter is input? Input deals with what? Input deals with, Markel. Yeah, the X's. Input deals with X's. Output deals with Y's. Output is Y's. That's your range. Make sense, Markel? Okay. Good, good, good. So let's look at a few examples to kind of help us through this and understand kind of what this means. Is anybody still writing that, or are we good? All right, excellent. All right, so for A, take a look at this. So to kind of give you a heads up, this circle right here is going to be your X. This circle over here is going to be your Y. Remember, what does X represent? Inputs. Yeah, inputs. Good. X represents inputs. And Y is your output. What's our number one rule here? What's our number one rule?
Every X has only one output.
Good. Every X has exactly one output. So take a look at this. All of my X's do not live in Texas. All right? But all of my X's, do they have one output? Yes, they do. They all have one output, exactly one output. So is this a function then if they all have one output? Yes, it is. Good. So it is a function. Go ahead and circle that. And maybe this will kind of help out a little bit. What is our domain here? What are all of our x's here? There you go. So our domain is 1, 2, 3, and 4. Good. Adam, what's our outputs?
It would be the 1, 3, 5, 7.
1, 3, 5, and 7. Fantastic. Notice, do any of my domains or do any of my inputs, are they any of those the same? No, they're not. Yeah, 1, 2, 3, and 4. Those are all different, right? The issue is when your domains are the same, that's when you start running into issues. It's not a function when the domains start repeating. So like when we look at letter B here, what's my domain for letter B here? What are my inputs? 3, 9, 3, and 4. All right, what is my range here? What are my outputs? 4, 8, 7, and 20. Now let me ask you, is this a function?
No.
So I got one no. Justin says no. Y'all agree with him or like, I still have no idea what he's talking about. Alessandro, you agree? Okay. Adam, you agree? You do? All right, so we got 3 yeses. The answer is, it is not a function. It is not a function. And let me kind of show you with a little more of a visual. All right? Same kind of visual we had over here. I'm gonna do one for this problem. So what are the inputs? 3, 4, and 9, right? Are we okay with that? 3, 4, and 9? Because there's 2 3s, I just wrote it down one time. We have the 4 and the 9. So let's put the outputs on there. The outputs are 4, 7, 8, and 20. And now every input has to have one output, and that's it. Okay? Can it have 2 outputs? No, it can't. Yeah, because the number 1 rule: every input has to have only one output. So take a look at 3. What's the output for 3? 4 and? Well, 3 goes with 4 and 3 goes with 7. So 3 goes with 4 and 3 goes with 7. Y'all cool with that? What does 4 go with? 20. Well, 4 only goes with 20, right? And then what does 9 go with? 8. So notice, one of my inputs here, the 3, it has multiple outputs. Is that good or bad? That's bad. That's why it's not a function. You can't have an input with multiple outputs. Okay? It can only have one output. Okay? It can only have one output. Alessandro, what's up? Why does 3 go to the 7?
Because the second 3 goes to 7.
Yeah, you see that 3 right there goes with that 7? And look up here, Alessandro. See, it says 3 to 4, so 3 goes with 4. 9 to 8, 9 goes with 8. 3 to 7, so 3 goes with 7. And then 4 to 20, 4 goes with 20. Does that make sense? So notice the issue is this 3 right here. We can't have an input with multiple outputs. We can't have that. It can only have how many outputs? One. Good work. All right, for C. All right, take a look at it. Who off the top of their head can tell me if this is an input? I'm sorry, if this is a function or not? Just by looking at it. Can anybody tell? You say it's not a function. Markel, what do you think? It's not a function? Why not? Because it has the same numbers? You're not far off. Okay? How about this? Let's make it a little bit easier. Let's write our domains down. Does that sound good? What's our domains here? Nice. 15, 10, 5, 10, and 15, right? What's my range? What are my outputs here? -10, -5, 2, 5, 10, right? All right, so what is the issue with this, Markel? What you said numbers are the same, right? What numbers are the same? So the 10s, right? The input, the 10, and then what else? Not the 5s. The 5s don't matter. The 5s, notice that 5's an input, that 5's an output. We're not worried about that. We're just worried about the inputs having multiple outputs. The 15s is the other one. So 15 and 15. Notice these 15s have multiple outputs. Uh-oh. Negative 10 and 10 are the outputs for the 15. For 10, our output is negative 5 and 5. Again, that can't work, so that can't be a function. Does that make a little bit of sense? Sort of? Yeah? Good, good, good. So the answer here is not a function. Not a function. Not a function. All right, we're going to keep the video rolling. This is going to be a long video, but that's okay. We're going to really, this whole video is going to be focused around functions and non-functions. All right, so for this one right here, what do we think? Is it a function or not a function? It's a function?
No.
Markel, stick with your first answer. Is it a function? Yes, it is a function. Again, do all of my inputs have a different output? Or I'm sorry, all of my inputs have to have at least one output. Notice none of my inputs repeat, do they? That's a good thing. That means it is a function then. It is a function. I know, Markel, did you get mixed up with the whole, well, 10 shows up twice? Is that what kind of got you? Yeah? And the zeros? And the zeros? Yeah. So let's look at our domain then. Let's write down, what's our domain here? Excellent. What's our range here? 20, 10, 0, 10. Good. So all we're focused on for the whole class here, if the domain repeats, it's not a function. That's what it comes down to, because those are our inputs. It doesn't matter about the output, okay? The outputs can repeat. See how there's two 10s right there? That's okay. The outputs can repeat, but the inputs cannot repeat, okay? The inputs have to have how many outputs? One, there we go. Every input has one output. I'm going to keep saying that probably the entire unit. All right? All right, this next one. What do y'all think? Is it a function or not a function?
Function.
You say function? You say function? Do we agree? Does every input have one output? Yeah, it does. So negative 8 only goes to 0, doesn't it? 24 only goes to 20. And 32 only goes to 32. So that is a function. It is a function. Now let's show you what a non-function looks like. Now if it looks like the next one, look at the next one. See if I can kind of get this right here. Look at the next one. All right, is that a function?
No.
No. Why? What sticks out to you?
Is it
What's repeating?
the 5?
The 5. Notice my inputs are 1 and 5. But what's going on with that 5? The 5 doesn't have just one output. It has two outputs. So is that a function? No, because it has multiple outputs. Remember, every input has to have one output. Only one output. Feel good about that? You do? Good, good, good. Amir, how you feel about that? Feel good? That's what I'm talking about, man. You look good. You look good, okay? Oh, this is a good one right here. I love these, okay? All right. Telephone number is our X. Person is our Y, okay? So that means telephone number is our input and person is an output. So what do y'all think just by thinking about it? Telephone number, person, is that a function or non-function? You say function? You do too? You say function? So let's just think about it logically. Does every phone number have one person? What do you think? What do you think? So my phone number, 770-362-2742. If somebody dials that number, are they going to get multiple people? No, they're only going to get how many people? One, and that's me, right? So, does every telephone number have one person?
Wait, what if it's like a company?
What if it's a company? Well, it went to that one company, didn't it? If you call that phone number, is it going to go to multiple companies? No. And again, this is talking about persons, right? Just the people. Yes. Mm-hmm. Exactly. When you call, if you call, McEachern High School, right? Guess where that number brings you to? The secretary in Russell Hall. Okay. If you call that number, are you going to get me? No, you're not. You know what I mean? Are you going to get Miss Montgomery? No. Are you going to get Adam? No. That one number is to one person. Does that make sense? So that has to be a function because that one to one. Last block, the kids were curious about, man, you know how many like wouldn't it be weird if like a number, like they ran out of numbers when it came to telephone numbers? Wouldn't that be weird? Do you think that ever happened? They ran out of telephone numbers? Start using letters? But I told them, well, actually, I learned this a little bit in college. If it takes, it's the number of combinations you can use for numbers is in like the trillions. It's insane how many numbers you can make with like seven. Think about what we have, our area code, right? We have 770, 404, we have 678. Do we have 470? Is that around here? 470. We have all of these just area codes, right? That's just for us. Every state and different, like almost county, I think. Maybe not county. But every state kind of has their own. Who does? Memphis? And so like North Carolina has 336. New York is what? 315? See, I think there's also in New York 918. That's another one. But you think, all right, you have those numbers, and then after that, you've got 3 numbers, and then another 4 numbers, right? Those numbers can be changed. You look at the very beginning. What's the first number you can make? Well, 0, 0, 0, 0, 0, 0, 0. So what? That could be somebody's number. 770, 0, 0, 0, 0, 0, 0, 0. Guess what the next number would be? Yeah, 770, 0, 0, 0, 0, 0, 0, 1. And it just continues to go up all the way. Once you get to 9, all right, once this gets to 9, it would be 0, 0, 0, 0, 0, 1, 0. Because you get the 10, right? And it just keeps growing like that for every single number. That's how numbers really are created, okay? And so I don't think we'll ever really run out of numbers. Because, again, it's in the trillions. It's a lot, a lot, a lot. Then you have like 1-800 numbers. All right, so the next one here, person and car. So when we think about this is our X, this is our Y. What do y'all think? Does every person have exactly, one car? So, is it a function? It's not a function. Exactly right. Does every person have one car? No. Some people have, they have 2 cars. You look at, the rich and, those professional athletes and actors and actresses, they have multiple cars, okay? So that is not a function. That is not a function. All right, last one here, shirt color and student. So let's go with the shirt color of, maroon. All right, does the shirt color of maroon just go with one student, or can multiple people be wearing a maroon colored shirt? Multiple people, right? I was thinking about it. Well, that's kind of what you and Justin are wearing. It's like a maroon right there. So that's what I was thinking. I was looking around. I was like, let's see here. Well, me and Link have blue on. So a blue goes with multiple people in this class, right? Look at white, or Jillian's wearing white. Jillian's the only one wearing white. Okay, so that's one output. But blue, we have multiple outputs, don't we? If you look at blue shirts or blue clothing in here, well, it goes to Lincoln and it goes to me. If you look at maroon, it goes to Justin and it goes to Adam. So is this a function?
No.
It is not a function. Good, good, good. It is not a function. All right, any questions on that? Yes, Markel. If it's not a function, what that means is, like, if you're wearing, like, what color hoodie is that? It's like a gray. So that's saying, like, if you have multiple people are wearing gray, not just you are wearing gray. You know what I mean? It's all right. So gray shirts. How many people are there? Is there just one person wearing a gray shirt, or are there a lot of people wearing gray shirts? In the class, if this were just our class, then yeah, it'd be a function, but you're the only one wearing gray, right? If you're talking about, it's just saying shirt color and students. So we're talking about probably all the students at McEachern, right? If you have a shirt color of gray, how many people do you think are wearing gray today? Is it just one? Or a lot? A lot. Oh, Alessandro's wearing gray now. Okay, so now it's not a function just in this classroom. But, Marquette, if you look back at this, like telephone number, right? Like my telephone number, no one else in the world has my telephone number, right? Well, you are?
Yeah,
Oh, that number?
yeah, I got that number.
Oh, I got you. Yeah. So every telephone number is designated to one person. A phone number doesn't have multiple people, right? That'd be kind of strange. If all of a sudden, somebody dials my number, and then, Dave answers. Hey, what's up, man? It's Dave. Oh, I was trying to get a hold of Zach. Oh, hey, just put the number in again. Maybe we'll get Zach next time. You see how strange that would be? All right. So telephone numbers, every input has exactly one output. Shirt colors, right? Blue shirts. Well, me and Link, if you look at us, if you look at blue shirts in the classroom, it goes towards Link and it goes towards me. So we have multiple outputs. Does that make sense? So we can't have multiple outputs to be a function. It has to have just one output to be a function. Does that make sense, Markel? Sort of, maybe? They do? Okay, good. All right, cool. Well, here we go.
Be sure to hit that like button, subscribe if you're new, and turn on post notifications as well. Bye.